So this is the initial use of our function interface, right? Okay, fine. Keeping a function somewhere, yes. So think of function interfaces as a function type. It is defining a function type. That abstract method is the function type, basically. Okay. Fine. So any questions now related to the function type? Yeah. Yeah, you can go through it again. This is the way we define the function interface, penalty function. Okay, and then we have done the change in the current account class. That was the first thing we did. We changed in the current account class so that it is using a penalty function, fine, where the computation is done like this. Okay, so by default, when a current account object is created, it has a penalty function, right, which computes to 200. Okay, fine. And because we made this to use this penalty function, fine, we had changed the withdraw method. Fine, we updated the withdraw method here. Okay, so that's the line where we have made the change, right? Okay, and so calling the compute method on the penalty object. Okay. Fine, with whatever is the current balance and the minimum balance, two parameters here. And so that was the change. And then what we did was, yes, we tested it in the test account class. Okay, fine. Okay, now let's make the penalty function still better. The function interfaces, the function remains the same. It's about the compute, right? That we are not going to change anything in the method signature there, right? So yes, we would like to add a few more things in the interface. It's an interface, right? And interface can hold it can have static and final variables. Okay, so let's see the change which we can make here. Okay. What we could do here is we can say, okay, to make things, the way we had done, what we could have done is we could have said, okay, let's have a public static and a final variable of type penalty. See, type is penalty equal to variable name. Variable name, let's call it as default. So instead of keeping like some lambda expression for the other users, this is the place where you keep the lambda expression. Okay, so we can have our lambda expression over here saying, okay, by default you have, so that same function what we have over there, that could have actually been given here. Okay, so if balance is less than, so balance is less than the minimum balance. Okay, in that case compute to 200, otherwise 0. Okay, fine. So if we do this, this is the first change I'm making. Okay, fine. There are still more changes, and there are still more additions to this which we'll make. Okay, but understand each addition as it is being done. Okay, so with this, yes, I can write slightly better code in the current account. Okay, fine. So in the current account, fine, the place where we were doing it, this part equal to, fine, what I'll do is I'll just say So this looks better. Okay. See, from the user's point of view, fine, user has, okay, you have put some default function, fine, put it as part of the function interface called penalty, and anyone can just, if he wants, he can just straight away use, oh, that's a default one. Okay. And so this is one. Next. Okay. Next change. So this is clear, right? It's nothing much, but yes, for users, yes, this looks as a better code rather than having all over the places so many lambda expressions at a number of places. And lambda expressions look wise, they don't look good. Right? This looks better. Okay. Okay. Let's look at let's add a few more things into this. So yes, we can make use of static variables also in this, right, in an interface. Okay, so using static variable in function interface can be done for this purpose. Another use what we are having is we would like to use a static method, okay, which can give us a function object. Okay, so we have this public static penalty. Okay, type is penalty. Okay, so fine. So we have public static, a static method now, which can give us a penalty function, and we'll say, okay, so maybe see, this is like, oh, I have a penalty function which always computes if it is applicable, if the penalty becomes applicable, it always gives me penalty of what I decide. Okay, so it's saying, okay, fixed. Okay, so we have a method called fixed, and it takes as parameter the penalty amount which is to be fixed. Okay, fine. So yeah, this is equal to, sorry, it's a function. And so this is a method which is taking a parameter, but what is the return type here? Function type. And the type is a function interface. And therefore we can write here like this, return, okay, and that qualifies for a lambda expression. We can write a lambda which looks like this. We can say, okay, there's a lambda which takes two parameters, balance, comma, minimum balance. Okay, so writing a implementation of that compute here. Okay, and what should it do? If balance is less than the minimum balance, okay, in that case, return P. Not fine. So it's actually someone who wants to create a penalty for a fixed, fine, he can just simply use this. Okay, see how it could now be used. Okay, maybe I can even clean this up also. See, anywhere someone was doing a lambda expression of this sort of a thing, right? This is in 200, but if someone was interested in keeping this lambda expression something like this, and it could have been done by saying 200. Okay, fine. Call that function. Okay, fine. From main method, someone could have said, okay, set penalty, penalty dot fixed, and give a fixed value. Okay. Similarly, someone could have said, okay, we have this penalty being computed as a percentage of the difference. Okay, maybe the penalty gets computed as a percentage of a difference. So I'm giving someone an option that if you want to go for this kind of a thing, yes, give me the percentage and I'll create a function for you. So basically, you're creating a function and returning from here. Okay, and what you are returning are functions. See, lambda expression, functional interface, right? The idea here is that functions are like objects. Fine. So treat them like any other type. You would have created an object of something by saying new, and maybe you say return new and something. Or similarly, we can say return and a lambda expression. So that's my function. Right? It's an object. Remember this. Lambda expression is nothing but an object. Okay. Because the return type of this method says penalty, therefore the context, it knows from the context. Oh, it's a return statement inside a method which is saying return type is penalty, and therefore the type of this is penalty. Okay, fine. So percentage, maybe we would specify 0.1 double type. Okay, double, let's say percentage. Yeah, let's say okay, yeah, okay, I'll just make it shorter. Okay. So what can be done here? Return balance, comma minimum balance. Okay, and maybe we might require a few statements. Right? So yeah, so first part is if it's not applicable, let it return a 0. Okay. Okay, first thing you can always do that long diff equal to minimum balance minus the balance. If diff is less than 0, return 0. Okay. Fine. Otherwise, now we can yeah. Okay, how do we compute the percentage? Fine, diff into p, right? Diff is equal to diff plus diff into p. Okay, fine, that percentage. So if it is 10%, yes, diff into 0.1 would be there, and therefore it would be 10%. Okay, let's check this now. So, but one thing here, you have to take care of the types. What is the type for p? Double. Okay, so diff into p will be computed as a double type. Okay, and when I add to the diff, it will remain a double, and I'm trying to assign to diff, which is actually a long type, and we want a long type basically. Okay, so this expression, right, this entire expression can be cast to a long. I think this is what we have to be returning, right? So instead of all this, we could have actually written in one statement also, the way we were doing earlier. Yeah, only thing to take care would have been the cast. Okay, anyway, let it be multiple statements. Return this. Yeah, it's sorry, diff, not diff plus, sorry, diff into, yeah, this is correct. What we are computing is the penalty amount. If the difference is 1000, fine, diff will be 1000 multiplied by 0.1. The amount of penalty is to be computed. Yeah. Okay, I think so. This is correct. Okay. Only thing it needed was cast as a long. Okay. So yeah, this could have been at that expression in the we could have written in this case fine, like this also. Okay, I'll do it here. Okay, so here this is the expression which goes here. Okay, so either okay, and so this can also manage it. Okay, so fine, so this is also okay. The point which I'm trying to drive here is that your functional interface, fine, can add methods, static methods, to enhance the applicable, fine, to enhance the usage, fine, make things easier for the users. Okay, fine. Well-known use cases. Oh, someone will go with percentage type. Someone will go with fixed value type. Okay, and therefore this is what you could do in such case to make it available. Okay. PER. Yeah. Yeah. Yes. Yeah. This is PER. Correct. Here, so it's a commented out thing, but let's update. Okay, fine. And the way it would be used, this function, fine, this static method. Okay, someone might use it from here, right, in the test account. Okay. Fine, we can see that this is currently on the basis of some kind of a block thing, but then okay, let's do the change again. Okay. Okay, I'll copy this and let's make changes here. So now we are saying set penalty. No, we are after set penalty. We don't need such a long thing because we are going to compute based on the yeah. Static method called percent and 0.01. Okay, maybe 10%, fine, or you could make it 15% also on 5. But before that, yeah, we have deposited 50,000 and then okay, so after depositing 50,000, let's have a display again so that we know from where we are proceeding. Okay, so on this okay, set penalty is fine. Okay, we're drawing 47,000. Okay. Okay, let's compile. Diff into percentage. Okay. Acha, earlier we were doing like that, right? So here, no, that diff will have to be written as this is current amount here. Sorry. Yeah. We'll have to write that diff. Instead of diff, what we have to do is write the Okay, minimum balance minus balance. That was it basically. Okay. Okay, so second time again he is trying to withdraw 47,000, but this time, okay, the penalty doesn't get applied because it is 57,500 and we are trying to, so his 500 still more than the required penalty thing. Yeah, we'll have to change the amount that is being withdrawn. Okay, what's the amount being withdrawn instead of 47,000? Let's make it 49,000. Okay. Yeah. So 57,500 trying to withdraw 49,000 and 15% is the so 47,500 minus 49,000, right? And then what is the difference from 10,000? How much is the shortfall? Okay, that would be multiplied by 0.15. Okay. Yeah. Okay. Fine. This should be mostly be correct, and we can verify later. Fine. So clear. The idea is it's not about just putting the abstract method in a function interface, but it is also providing additional provide some additional convenience to the user of the function interface. Okay, always think on those lines. Okay. And additional, no more abstract methods. That's fine. You have only one abstract method, but other things can always be there. Okay, static and default methods. Right. So we will come across when later when we look at the standard function interfaces which are available from the Java library, we will find that those contain static and default methods like this, okay, which are convenient methods. Okay, fine. So any questions now?